You are listening to Ethereum, blockchains, digital assets, smart contracts, decentralized autonomous organizations by Henning Diedrich. Bitcoin made headlines everywhere, but here's what most people miss. The real game changer isn't the digital money itself. The revolutionary force lies in the underlying technology that makes it all possible, blockchain. This technology has sparked fierce debates. Some believe it will completely eliminate traditional banking. Others see it as the foundation for unbreakable contracts and ultra-secure data storage. Then there are skeptics who dismiss everything as temporary hype destined to collapse. After exploring blockchain expert Henning Diedrich's insights, you'll understand why determining Ethereum's ultimate destination remains an open question. Let's start with how this digital revolution began. The 1980s brought computers into homes and offices worldwide. But this technological shift alarmed certain individuals who envisioned a dystopian surveillance state reminiscent of Orwell's nightmarish future. A small group of programmers decided to resist using their most powerful weapon, computer code. The cypherpunk movement emerged in the late 80s with one primary mission: safeguarding digital privacy. Eric Hughes, an American programmer and movement founder, outlined their vision in his 1993 publication, A Cypherpunk's Manifesto. These digital warriors wanted secure, encrypted communication that would enable anonymous transactions, essentially creating digital cash that worked like physical money at your neighborhood store. Their first breakthrough came in 1997 with the cypherpunks' distributed remailer, an anonymous email system that operated without central control. Soon after, someone using the pseudonym Wei Dai introduced B-Money, the first cryptocurrency prototype. B-Money operated remarkably similarly to today's Bitcoin. Every user maintained a copy of all transaction records, allowing anyone to view, approve, or challenge each payment. However, B-Money lacked one crucial element that Bitcoin would later solve: a decentralized method for maintaining accounts. Other digital currency experiments followed, but the dot-com crash around 2000 killed them all. Nearly 10 years passed in silence. Then 2008 arrived, and Bitcoin emerged as the planet's first truly decentralized digital currency. Bitcoin's creator, known only as Satoshi Nakamoto, remains anonymous to this day. Yet Nakamoto's goal was crystal clear: eliminate the need for traditional banks and central financial institutions. Bitcoin operates without any central registry, enabling direct transactions between users. So what exactly is a blockchain? Think of it as a secure, shared database storing transaction information. While blockchains serve many purposes, Bitcoin popularized the concept. For this digital currency, the blockchain records how many Bitcoins transfer between accounts. Simple entries like account A sends 10 Bitcoins to account B. The name blockchain comes from how data gets organized. Information gets stored in sections called blocks, connected in a precise sequence that creates a data chain. The first block, called the Genesis block, begins the chain. Each subsequent block contains information about its predecessor, linking them together. Picture Russian nesting dolls, where each doll contains all the smaller ones inside. Decentralization makes blockchain truly revolutionary. This feature prevents fraud because most digital items get copied easily. Just consider how effortlessly you can email photos or music files. Digital currencies need protection against duplication to maintain real value. Blockchain solves this problem by distributing the database across numerous computers. If you own 5 Bitcoins, this information isn't stored on one machine. It gets synchronized across an entire network. Attempting to change your balance from 5 to 15 Bitcoins would appear on everyone's copy, allowing others to reject your fraudulent modification. Cryptography provides another security layer, explaining why we call these cryptocurrencies. This mathematical science enables secure communication and data storage, while adding authentication to blockchain transactions. Every transaction requires a digital signature that uses cryptography to verify authenticity and prevent tampering with historical records. Understanding how cryptocurrency transactions work without central banking reveals the technology's true innovation. Blockchains operate through something called proof of work, a consensus protocol ensuring the blockchain accurately represents every transaction. Individual computers in the network, called nodes, must agree on one true version of the blockchain. Nodes actively participating in this consensus-building process earn the title of miners or validators. Getting all nodes to agree presents challenges. They must decide transaction processing order and what each new block should contain. Sometimes nodes propose different, conflicting ideas for the next block. Despite these disagreements, one chain always emerges as the longest or heaviest, the version ultimately approved by the consensus protocol and considered true. This becomes the world state. This process consumes enormous energy. Maintaining Bitcoin's blockchain for 1 year requires as much electricity as Ireland uses annually. To compensate for these electricity costs, miners and validators receive 12 Bitcoins for each block they successfully add. Decentralization makes blockchains slower than conventional databases. Traditional databases like MySQL process new entries in milliseconds, while Ethereum, today's most advanced blockchain, takes roughly 3 minutes per entry. However, blockchains still outperform many financial systems. Stock market transactions take approximately 3 days to finalize, making blockchains about 1,000 times faster. Compared to credit card payments, which take around 4 months to complete, blockchain transactions are roughly 100,000 times quicker. Blockchains extend far beyond digital currency storage. They can create binding agreements between multiple parties, potentially revolutionizing contract management. Traditional contracts face countless obstacles that can prevent parties from fulfilling their obligations, leading to exhausting legal battles. Blockchains offer a solution through smart contracts. Smart contracts don't just store agreement details, they execute contract terms automatically. These are legal documents written as computer programs and inscribed into blockchains. Since blockchains never forget anything, smart contracts execute precisely on schedule. A blockchain smart contract can trigger payments at specific times, whether using cryptocurrency or traditional credit cards. It can also guarantee digital goods like music or video files get transferred to designated email accounts. Smart contracts enable decentralized autonomous organizations, DAOs, to function. Bitcoin and Ethereum represent examples of these code-based companies managed by blockchain technology. DAOs operate through interconnected smart contracts that work together to perform various functions. Imagine a self-driving car that not only navigates itself, but also handles its own maintenance. Some smart contracts function as the engine, others pay for fuel or charge the battery. While the car represents an independent organization, it could join a larger network like Uber. When problems arise in DAOs, determining responsibility becomes complicated. Who gets blamed when there's no traditional management structure? Blockchains definitely aren't just hype. The technology has already demonstrated its potential to transform commerce and finance, but several issues require solutions. One significant problem: blockchains can lose data. While uncommon, this has already happened to Bitcoin's blockchain. Data loss occurs when large computer network groups responsible for storing information disagree about the blockchain's correct state. This disagreement causes the network to fork or split. You could ask two nodes about your Bitcoin account and receive different statements if each node sits on opposite sides of a split network. This scenario would create nightmares for financial institutions using blockchain technology. Network splits also happen when connections between nodes get severed, creating isolated groups. However, these splits resolve once connections get reestablished. The network always accepts the group with the highest computing power as the true blockchain state. The longest chain requires the most power and gets considered most current. Unfortunately, this means all transactions made on the smaller, rejected chain disappear. Another blockchain limitation: complete anonymity remains impossible. Every transaction needs sender and receiver addresses, pseudonyms consisting of long letter and number strings like 17 FHXHDB8. While these addresses don't reveal names, transaction details remain visible to everyone. Careful observers can analyze transaction patterns to potentially identify users, real identities. This confidentiality issue, particularly concerning sensitive data like medical information, might prevent widespread blockchain adoption. However, solutions may emerge soon. Unless you're deeply familiar with blockchain technology, you probably haven't heard of Ethereum. But this recent blockchain development deserves attention. Bitcoin pioneered blockchain technology, but remains limited to monetary applications. Ethereum represents a general-purpose blockchain, making it incredibly versatile. Beyond cryptocurrencies, Ethereum enables building land title registries and rating systems similar to those used by eBay and Amazon. Vitalik Buterin invented Ethereum in 2013 to solve problems that specialized blockchains faced when applied to other uses. From conception, Ethereum was designed to excel at multiple functions, making it today's most advanced blockchain. Like other DAOs, nobody owns Ethereum. It's free and highly accessible thanks to an intuitive programming language called Solidity. Ethereum includes its own digital currency called Ether, used for paying transaction fees, running calculations, and storing data on the Ethereum blockchain. While Bitcoin dominates today's cryptocurrency landscape, Ether could become the preferred digital payment method thanks to its more adaptable blockchain technology. Ethereum's potential applications make it particularly exciting. The Ethereum blockchain could make voting virtually tamper-proof. Each voter would use their signature to create a blockchain entry representing their vote. The proof-of-work process would prevent anyone from changing votes, while making vote counting completely transparent. Land title management represents another promising application, especially in developing countries where ownership confusion hampers economic growth. Ethereum's blockchain would make this process fully transparent and straightforward. Banking presents obvious opportunities. Major banking corporations already fund blockchain research because financial markets and asset trading could benefit enormously from blockchain's transparent and programmable nature. These examples barely scratch the surface. Ethereum could enhance escrow payments, social networking, ride-sharing, employment services, crowdfunding platforms, and countless other applications. However, since Ethereum operates as open-source software without warranties, questions arise about its trustworthiness. This concern matters enormously for large corporations that demand completely reliable, bug-free systems. Ethereum's developers haven't yet made serious efforts to prepare it for corporate adoption. Government regulation poses another potential challenge. Blockchains can facilitate criminal activities like money laundering and black market transactions, potentially prompting governments to impose heavy restrictions or even ban blockchain technology entirely. Nevertheless, blockchains possess the potential to transform our world as profoundly as the Internet did. Currently, Ethereum could become the blockchain of the future because it's the most advanced we've seen so far. Its general-purpose design, rather than highly specialized functionality, enables use across diverse social and commercial areas. Found these insights valuable? Hit like and subscribe for book summaries that could transform your thinking. The purchase link for Ethereum, blockchains, digital assets, smart contracts, decentralized autonomous organizations is waiting in the description, and we're curious which of these concepts resonated most with you. Drop a comment below